So we are given that angle theta is acute, which means it's in the first quadrant and all trigonometric functions are positive. And cosine of theta is equal to 6 out of 7. And we have to use a Pythagorean identity to find sine of theta. So let's use the basic Pythagorean identity of sine squared theta plus cosine squared theta equals to 1 to calculate sine of theta. We are given cosine of theta is equal to 6 out of 7. So let's replace that instead of cosine of theta in this expression. So we will have sine squared theta stays the same plus, instead of cosine squared theta, we will write 6 out of 7 instead of cosine, and it's still squared, equals to 1. So we get sine squared theta plus 6 to the second out of 7 to the second equals to 1. So this is equal to sine squared theta plus 6 times 6, 36. And 7 squared is 7 times 7, which is 49, equals to 1. Now we can solve for sine squared theta. We are adding 36 out of 49. The inverse of that would be to subtract 36 out of 49. Whatever we do to one side of the equation, we want to do the same thing to the other side. So 1 minus 36 out of 49. So this adds up to 0 on the left. And we get sine squared theta equals to 1 minus 36 out of 49. We need a common denominator of 49, so I'm going to rewrite 1 as 49 divided by 49, which gives us 1 as well, and it's minus 36 out of 49. So sine squared theta is equal to 49 minus 36 out of 49, and we get sine squared theta is equal to, the difference between 49 and 36 is 13 out of 49. So sine squared theta is equal to 13 out of 49. We need to solve for sine of theta, so sine is squared. The inverse of squaring is a square root. Whatever we do to one side, we need to do the same thing to the other side. So square root of 13 out of 49. Square and a square root will cancel. And we get sine of theta equals to radical 13 out of radical 49. We can rewrite 49 as a 7 squared. So we get sine theta equals to square root of 13 out of square root of 7 to the second. Square root and the second power will cancel, and we get sine theta equals to radical 13 out of 7, and this is our final solution. That's all.